Hi, everyone. I'm Alex Spinelli, VP of Machine Learning at Google. I'm joined by Diane Wu, Director of Machine Learning, and Lawrence Moroney, our lead artificial intelligence advocate. We're excited to talk to you about where we are with the Google AI ecosystem and where we're going. Okay, let's get started. According to the World Economic Forum, we are on the cusp of a fourth industrial revolution. This will blend the physical and digital worlds in ways we couldn't imagine only a few years ago. Advances in machine learning and AI will help usher in these exciting changes. Application development will change forever. This means it's absolutely imperative that we scale and democratize ML and AI in trusted, helpful, and ethical ways to make it easier to deploy great experiences safely. Machine learning is transformative. It opens up new scenarios that were simply impossible a few years ago. Here's what I mean. Photobombers beware. Magic Eraser on Pixel can quickly and easily diffuse you. Great. Now I need to find a new way to ruin my kids' selfies. Here are some more wonderful applications coming from our community, from you. Like Huradox, which uses machine learning to widen access to human rights information. They use BERT and TensorFlow to build a classifier that would take human rights-related text and assign human rights topics. Or the really fun Print Nanny from Lee Johnson, who used computer vision to detect 3D printing failures early and then stop the process. So clearly, applications are getting smarter and better at finding ways to help us, whether they're online or off. But machine learning is more than just building models. To be successful, you really need the entire ecosystem. You need a pipeline. From data gathering to data cleansing and management, through training pipeline controls, deployability and interoperability to a variety of surfaces, from the highest scale clouds down to the tiniest microcontrollers. All while ensuring every step of the way, we're responsibly building apps that are beneficial and never unintentionally harmful. This is what motivates me to come to work every day. I get to play a part in the only ML ecosystem that covers everything, allowing you to use free and open source software at every part of the pipeline. And I get to help our developer community transition away from traditional coding as we create the ecosystem of tools they need so you can take full advantage of the new paradigm that is machine learning. I'm also delighted to be part of this vibrant, exciting community of software developers, millions strong, who've taken the leap to explore and use machine learning. We're all on this journey together, innovating with new technologies to make building helpful apps more efficient and, hey, more fun. So now let's take a closer look at our ecosystem, starting with data. Diane?
Thanks, Alex. Hi, I'm Diane Wu, Director of Product Management for Machine Learning at Google. If you're building machine learning models, you're probably spending a lot of time thinking about your data. A machine learning model is only as good as the data that's used to train it. So we want to make sure that you have the best tools to acquire, label, pre-process, and ingest high-quality data for your modeling needs. With tools like TensorFlow datasets, a collection of ready-to-use datasets from Google and the community. You can access them with just 1 or 2 lines of code, and they are incredibly useful if you want to quickly prototype a model. For example, perhaps you want to build a model for spotting crop diseases and want to see if you can build a predictive model with high accuracy and precision. The Cassava dataset is ideal for this, and you can retrieve it using just a few lines of code with TensorFlow datasets. And evaluate the performance of a simple model before you spend time gathering and labeling additional data. With dozens of datasets across a variety of domains, there's something for everyone. When I'm looking through datasets for inspiration, I often turn to Kaggle. Kaggle hosts one of the largest communities of data scientists and machine learning engineers in the world, with over 10 million users, 10,000 public datasets, and over 600,000 notebooks. We learn best when we learn from each other. And in the spirit of learning from each other, Crowdsource is Google's effort to bring global representation to our ML datasets. It's a gamified mobile app used by people around the world to answer simple questions like, is this a picture of dim sum? Or is this the right translation in Arabic for a given sentence? By crowdsourcing these answers, developers can generate data representing hundreds of languages and cultures and use it to train more inclusive models. Once you've found your dataset and you're ready to start training your model, you can use the TensorFlow data APIs to cleanse and pre-process that data and prepare it for training. When it comes to machine learning, a lot of academic focus is placed on model architecture and hyperparameter tuning. But when you actually look at the code that's written, this part is for the model, and this is for the pre-processing of data. So we build infrastructure that helps to simplify pre-processing and reduce the time that it takes to build a model. The TF record format and TF data APIs make it much simpler to complete important data preprocessing tasks, like slicing, splitting, shuffling, sharding large datasets, augmentation, and a lot more too. But you don't need large datasets to be successful with AI and machine learning. Turn up the music and check out what the Beyond Imitation folks did. Their app gives you a virtual dance partner. It runs with TensorFlow.js and is trained on just a few megabytes of data, which is open sourced along with the code. And like any part of the development process, it's important to build machine learning products that behave responsibly and reliably. We've been working hard to bring you the tools that help you understand your models and data and anticipate how they might perform under different conditions. These include the Know Your Data tool, which can help you spot biases in your data that might lead to unintended consequences in the trained model. Know Your Data is a powerful way to quickly spot issues and is currently available for well-known datasets. Know Your Data can help you quickly identify correlations in your data that would inevitably be reflected in your trained model. Such correlations, like the one between perceived gender with different types of activities that we found using Know Your Data on Coco Caption, can lead a model to perpetuate unfair biases or stereotypes unintentionally. Beyond dataset analysis, we've also expanded the capabilities of the Language Interpretability tool, or LIT, a tool that helps developers interactively probe their model to better understand, test, and debug its behaviors. We want LIT to bring cutting-edge interpretability techniques directly from research into the hands of ML practitioners. So we've included a few methods like TCAV, which stands for Testing with Concept Activation Vectors. TCAV tells you how important a high-level concept, like perceived gender, is for a prediction class. And you can use TCAV after training without having thought of the concept of gender before training. This is not magic, and you can see how it works while using LIT. We've also made LIT more broadly accessible, as it's now available to all of our cloud users through notebooks. Finally, and most importantly for many of you, as part of our extension of LIT, we have preliminary support for tabular and image models. And now is time for the next step, training your model. And Lawrence is here to tell us all about that.
Hi everybody, I'm Lawrence Moroney, the lead artificial intelligence advocate here at Google. And I'm really glad to be here with you today, so let's talk about training. When you start your ML journey, it can seem so alien, complex, and maybe very abstract. Because you're used to writing code to solve problems, but this new paradigm has you training a model to do it for you. So how do you even get started? Well, I got good news for you. With the Google AI ecosystem, there's a variety of coding APIs that are easy to understand, code, maintain, and of course debug. I'll start with Keras. It's designed to make bringing AI models to code very easy, with an API that works from the simplest Hello World models all the way up to cutting-edge, research-oriented models like this one, which incredibly can understand what an AI pays attention to when it's classifying an image, and which can segment the image into backgrounds and people. There's also some great research stuff that's been done in Keras, like this Pathfinder model from the folks in Google AI, to this wonderful solution from the community. It detects hidden objects behind larger objects using radar and convolutional neural networks. And maybe you saw it in the developer keynote. And if you're developing for mobile or embedded applications, I'd love to introduce you to TensorFlow Lite Model Maker, which, as its name suggests, is designed to take on complex tasks in model creation, such as data processing, training, evaluation, model optimization, conversion, all that good stuff, and wrap them into easy-to-use APIs that can create production-ready TensorFlow Lite models. Your code is then reduced from this to this. Model Maker leverages transfer learning, which greatly reduces the amount of training data and shortens the training time. The next step is to integrate your model into your mobile app, and deployment can be difficult. The clue is in the name, TensorFlow. Tensors flow in and tensors flow out. But you're probably more used to dealing with bitmaps, strings, and CV pixel buffers than you are with tensors. So we created the TensorFlow Lite Task Library to help with using the model on multiple platforms. And right here at I/O, we're delighted to announce that TensorFlow Lite Model Maker and the Task Library now support on-device large-scale similarity search through the Searcher API. Powered by a model called SCANN, Google's cutting-edge similarity search, the Searcher API helps you find similar images, text, or audio from millions of data samples in just a few milliseconds. For example, in a photo gallery app, users can select a birthday party photo, and the model will find similar photos from their photo gallery. And since all of this happens on-device, no user data is sent to a server, so your user's privacy is maintained. And I'd also like to announce that the task libraries are now fully available to iOS as well as Android developers. One piece of feedback we often get when it comes to writing code for machine learning is from developers who want to get started, but they can't afford or justify the hardware investment. To that end, we've made Colab available. It's a browser-based IDE that can run on just about any computer, and it has free GPU and TPU resources on the back end that you can use to train your ML models. Like Carol Lowe from the United Kingdom. Carol chose to do her master's in cybersecurity, and her dissertation was on detecting deep fakes. But being new to deep learning, she didn't know that she would need a GPU to be able to finish her project effectively. And for many, when you're a student, every penny counts. So when she saw how much a computer for deep learning might cost, she thought she'd probably chosen the wrong topic. And then she discovered Colab and was able to use it to complete her research, saving thousands. Or Muni Swaran from India. He couldn't afford compute resources when he was an undergraduate. He was spending hours waiting for his neural networks to train on his CPU until he discovered Colab. With this, he was successful in learning ML, and he has now completed our TensorFlow Professional Certificate and works as a machine learning engineer. Of course, the ecosystem isn't just for getting started. The same frameworks and skills can apply to huge solutions too. So when you want to train across massive infrastructure, like TPU clusters, the APIs make it simple through a distribution strategy. Your code will change from this to something like this. Let me share an example of a company that we've been working with to support training their models on TPUs. Cohere.ai recently updated their extremely large language model to train on the newest V4 TPU clusters, and they've improved training time by 70%. With this language model, they provide an API to developers that can let you do things like content moderation, semantic search, categorization, and a whole lot more. Now, it's all very nice to have a model, but your users still need to be able to access it. So next, we're going to take a look at the deployment options, and right back to you, Diane.
Thanks, Lawrence. It's so inspiring to see developers leverage Google Scale compute and infrastructure to train models with state-of-the-art capabilities. But the journey doesn't stop there. Once you've trained a model, now you need to deploy that model into production. And we've built the tools to give you greater flexibility for how and where your models can be used. When using TensorFlow, you can deploy your models anywhere from the scalable cloud to the web, to the browser, to the mobile device, embedded systems, and even microcontrollers. But that's just the beginning of your app story. Deploying a single model often isn't enough, and models will need to be constantly updated. For bug fixes, for the latest updates based on new data, and to ensure that responsible AI issues are addressed as quickly as possible. If you're creating a product, you need a production-level process. For machine learning, you'll need an MLOps process and infrastructure, and TFX is a great place to start. As the world and your businesses change, you'll need not only CI/CD, but continuous training too, and TFX makes that possible. TFX also helps you understand your model's performance at a deeper level, so your customers have a great experience with your product. You can train models in TFX for your mobile, web, or server-based applications, and you can run TFX just about anywhere, including in a web browser with Colab. It's in use by many Google products and by companies like Spotify and Twitter. With over 10 million downloads, chances are pretty good that you already use an app or service that uses TFX. As you work to build responsible machine learning systems, model cards help provide context and transparency into a model's development and performance. We're delighted to announce that you can now easily generate them using the Model Card Generator TFX pipeline component. A very popular API in TFX is TensorFlow Serving, which allows you to deploy your models on a server and perform remote inference. So today at I/O, we're launching 4 new learning pathways for Android, iOS, Flutter, and web developers to learn how to deploy a model to TF Serving and use it on their platform of choice. And when it comes to deploying on mobile, we've gotten great feedback from Android developers who love using TensorFlow Lite, but don't like the burden of deploying the runtime with their app and continually updating their app to get the latest version. So we're delighted to announce that TensorFlow Lite runtime is now available in billions of devices via Google Play services with regular updates. That way, you know your users will have the latest, fastest version of TF Lite, and that your APK size will be much smaller. Several Google teams, including MLKit, already use TensorFlow Lite in Google Play services, serving over 400 million monthly active users, running over 20 billion daily inferences. And you can benefit from this technology today with our public beta API. Having a platform that empowers developers like you to build inspirational solutions is what really excites me and gets me up in the morning. And none of it would be possible without you, the great community of developers that make it real. And with that, I'll hand it back to Alex to share some exciting updates.
Thank you, Diane. Wow, we've seen lots of great stuff today. All about how the tools from Google AI empower you to succeed in machine learning, whether you're taking your first steps as a learner or building massive language models like Cohere.ai. If you're curious about how it all works, even if you aren't technical, we have a terrific specialization called Google AI for Anyone that we released on edX. It helps you understand not just what AI and ML are, but just as importantly, what they aren't, cutting through all the hype to inform you and hopefully inspire you about what's possible. Like the amazing boot camps we ran in Korea over the last 2 years, where we partnered with local companies so graduates would get a TensorFlow or Google Cloud certificate to work towards a job or internship at one of the sponsors. And inspired by that, we're expanding to India, LATAM, Turkey, Africa, and Japan. To stay connected, we also have an extensive network of Google developer groups and TensorFlow user groups. With in-person meetings becoming more possible now, there's never been a better time to connect. There are lots of amazing tools to help you across your entire ML pipeline. We've invested heavily in creating an end-to-end ecosystem to help you succeed with machine learning no matter how or where you use it. We highlighted a few of them today, but you can find the rest on the Google Developer Properties. I'll share the URLs in the description below. So to wrap up, a really big thank you to everyone who's helping make the world a better place with AI and machine learning. It really is a joy to work alongside you, each and every one of you, and I'd invite you to continue the conversation on our TensorFlow forum, where members of our teams are always happy to answer your questions. I really hope you're now motivated and looking forward to going on an inspiring new journey with machine learning. So thank you and enjoy the rest of I/O.